Hey everyone! Today we're going to be talking about changes of state. So to start us off, I made us a little changes of state diagram. So we have we have solid to liquid, liquid to solid, then we have liquid to gas, gas to liquid, and then finally solid to gas and gas to solid. So those are 6 changes of state that we're going to be talking about today. So the first one is solid to liquid, and that's melting. So that's the transition from solid to liquid. And then according to kinetic theory, as a substance melts, the particles gain kinetic energy and move further apart. And the melting point is the temperature at which this transition occurs, at the temperature at which these particles gain kinetic energy and move further apart from each other, going from a solid to a liquid. So the molar heat of fusion is the amount of energy which is needed to change 1 mole of a substance from its solid to liquid state, and this is measured in kilojoules per mole. Because according to kinetic theory, the particles need to gain kinetic energy to move further apart in order to transition from solid to liquid, and therefore you need to add energy in, and the amount of energy you need to add to change 1 mole of a substance from solid to liquid is the molar heat of fusion. And then over here, mind the units, right? So kilojoules per mole. So that was pretty simple. That's our first change of state from solid to liquid. I'm sure we've probably all heard that one before. And the next one I think we've all heard of too, which is freezing. So that's liquid to solid. So transition from a liquid to solid. And then looking at the definition again through kinetic theory. It says as a substance freezes, the particles lose kinetic energy and they come closer together, right? So sort of the opposite of what we just saw here with melting, where we're gaining energy and moving further apart. For freezing, it's we're losing energy and moving closer together. We have freezing point, which is temperature at which the transition occurs. The melting point is the same as the freezing point, so they occur at the transition occurs at the same point, except for melting, you're going from solid to liquid, and then freezing, you're going from liquid to solid, but it's the same temperature. So, the molar heat of fusion is the same value as the molar heat of fusion for freezing is the same value as the molar heat of fusion for melting, except it is the opposite in sign, and here's the reason why. Over here, you're adding energy in order to make the particles gain kinetic energy, move further apart, and melt. But over here, you're taking energy out, so they come closer together, and that's why it's the same amount of energy, except it's going to be opposite in sign. So those are the first 2 changes of state we have here from solid to liquid. Then we have another 2 changes of state that we're going to discuss, which is liquid to gas, and then gas to liquid. So liquid to gas is vaporization, and that's just a general term for the transition from liquid to a gas. And the particles gain enough energy in order to break and move far away, therefore going from a liquid to a gas, right? So there are 2 types of vaporization that we're going to talk about, and the first one is evaporation. So this only occurs on the surface of a liquid. So the particles on the surface gain enough kinetic energy in order to break away from the other particles and turn into gas instead of being part of this liquid. And this is dependent on things such as surface area, heat, and other forms and sources of kinetic energy that can access the surface of this liquid. Because once it gains this energy, it can break away and move from a liquid to a gas. The second type of vaporization we're going to be talking about is boiling, and that occurs throughout the liquid. So first let's start by talking about vapor pressure. So vapor pressure is the amount of force of the liquid trying to push up into the gas phase. So atmospheric pressure pushes down on this liquid per se, right? So vapor pressure can't just it has to exceed this atmospheric pressure in order for it to become a gas, right? So you have this vapor pressure where your liquid's trying to push up into the gas phase, but this vapor pressure is pushing down on it. And if you want it to break away and from the liquid and become a gas, it has to exceed this atmospheric pressure. So there are 2 factors that kind of change or affect boiling, and that's the temperature and the amount of pressure. Because if there's less atmospheric pressure for it to break through, it will boil easier. And then if you increase the temperature, it'll be given more kinetic energy, which will help increase the vapor pressure and help break through this atmospheric pressure. So as you can see, evaporation is a lot more passive compared to boiling, where you have these factors like temperature and pressure, and you can kind of manipulate them to make it like boil faster, or while like you have in evaporation, it's more like passive. It's just like it's more dependent on like the environmental surroundings and things like that. The fourth one we're going to be talking about today is condensation, and that's from gas to liquid. So it's kind of the opposite of this, right? So the particles of gas lose enough energy to coalesce into a liquid. So the molar heat of vaporization is just kind of the same concept as we were talking about before with the molar heat of fusion, right? So the molar heat of vaporization is the amount of energy that you need to convert 1 mole of liquid to a gas, or 1 mole of a gas to a liquid at the boiling point or condensation point. And like we said, that's the same temperature. The same thing as we said, like freezing and melting point on the same temperature. In the same way, the boiling point or the condensation point or condensing point is the same temperature, right? So the molar heat of vaporization, maybe I'll write this down just in case. The molar heat of vaporization is the amount of energy needed to convert 1 mole of a gas, of a liquid to a gas, or vice versa, right? So we can also convert 1 mole of a gas to a liquid at the boiling or condensing point, which is the same temperature, like same concept that I mentioned with the melting and freezing point, right? And yeah, it's just kind of the same idea as this molar heat of fusion. And so, right, for the molar heat, for boiling, right, when you're converting it from a liquid, or for vaporization, when you're converting it from a liquid to a gas, it's going to be positive, whereas for condensation, it's going to be negative because you're losing the energy in order to coalesce it into a liquid. Okay, so these are the first 4, right? And I think we're all pretty familiar with like melting, freezing, vaporization, condensation. I'm sure we've all heard these 4 before. So I think these last 2 are going to be a little bit more tricky, but I think we can still get it. And if you have any questions, as always, leave them down below and I would be happy to help you answer them. But the last 2 we're going to be talking about are from a solid to a gas. So that's going to be sublimation, and then from a gas to a liquid, which is deposition. So we're not going to go into a lot of detail about this, but just like the basic idea so you know that this is a thing, and hopefully you can learn a little bit about these concepts. So for sublimation, you're transitioning from a solid directly to a gas without even entering the liquid phase. And I know this might be like a newer concept. You're like, oh, how do you like do it without going to like a liquid phase? How do you go from solid to gas without even entering this phase? And the answer for this is pressure, right? The pressure has to be adjusted in order for something to sublimate, right? So everything has the ability to actually sublimate, to go from a solid to a gas without even going to the liquid phase, but you have to adjust the pressure for that. One example is dry ice. I don't know if you've ever played with dry ice or you've seen it, but that goes directly, I think, from a solid to a gas, and that's composed of, I believe, frozen carbon dioxide, right? So that's one example. So I know this might be a fairly new concept, but the way to like think about it is it's just an adjustment of the pressure, and that's how you're able to go from a solid to gas without even entering the liquid phase. Then the other one, where we go from a gas to a solid, is actually called a deposition. And like the others, it's kind of the opposite of a sublimation. So it's the transition from a gas directly to a solid without even entering the liquid phase, right? And like we said before, it just means that the pressure has to be adjusted. So yeah, those are the 6 changes of state. Hopefully, I know these last 2 might be a little bit new, but hopefully they make sense. If you have any questions, please feel free to leave them down below. Hopefully you can use this diagram to help you remember everything, all 6 changes of state. And thank you so much for watching this video. I hope you have a great day.